Hello, great stuff. Welcome to this session. Thank you very much for joining me today. And today we're just gonna be doing finance and just be looking at some quick revision for financial mathematics grade 12. Okay. Okay, let us look at financial mathematics. This is from CAPS and it's just indicating the progression of this topic from grade 10 to grade 12. You know that in grade 12 you learn about simple and compound growth formulae, and it's what you call simple interest formula and compound interest formula, and how to solve problems including interest, higher purchase, inflation, population growth, and other real life problem. So when you reach grade 12, you were taught also how to use the simple and compound growth formula again, and how to solve problems including straight line depreciation. You learn about straight line depreciation and depreciation on reducing balance that was covered on grade 11, and the effect of different periods of compounding growth and decay. For example, if we say it's compounded monthly, you know that on your interest you have to divide by 12 because we have 12 months in a year, and you have to multiply your number of years with what, with 12. So if it was compounded yearly, divide by 1, then and multiply by 1. Compounded weekly, divide by 52. Compounded annually, I mean semi-annually, you divide by 2. Compounded quarterly, you divide by 4 on your interest and multiply by 4. So you also cover this mostly with calculating effective and nominal interest rates. So you did that in grade 11. Let's go to grade 12. Now the focus on grade 12 is you have to know how to calculate the value of n from the formula of compound and simple interest, right? So and you know that to do so you're gonna use logarithms, where you just need to apply logs both sides and they apply the logarithmic rules. So also now in grade 12 you have to apply the knowledge of geometric series to solve annuity, very important, annuity and bond repayment problems, and also critically analyze different loan options. So this is just what we're going to be focusing on today. We just be looking at annuities and bond repayment problems, and also critically analyzing some loan options. Okay, great stuff. Like I said, today we're gonna be focusing on annuities, right? So we have two types of annuities. We have future value annuity and we also have present value annuity. But in this side, I just want us to focus on future value annuity. But before looking at it, you have to really understand what is an annuity, right? So in grade 11 and 10 you've been learning about maybe someone just going to put money and leave it in the bank so that maybe after 10 years it might gain some interest. So we call that money a lump sum, right? So you just go in a bank, you just put money, and you say, okay, let's use compound interest for 10 years, and that's all. You just forget about it. After 10 years you need your money. Obviously it has gained some interest. So that one is about compound interest and lump sums and all that. But then with an annuity is quite different, right? So with an annuity, what do? You make number of equal payments at regular intervals of time, right? So you are paying a certain money that is fixed every time. For example, a person may say, I want to be depositing 200, 200, 200 every month. So what we call an annuity is when a number of equal payments are made at regular interest of times, right? And subject to a rate of interest. And you are not just paying that money, you are getting specific interest at that particular time. For example, someone who's putting 200 every month, they might say, we will be giving you 12% compounded monthly You understand? So we call that amount what? An annuity. It leads you to an annuity because money is paid at regular interval of time. So we consider two types of annuities, namely future value annuity and present value annuity. Just different in their function. Why are you paying that money? For example, a person can be depositing that money every month in order to prepare something for future. For example, at your home, they must start paying, maybe your parents start depositing 500 every month in order for them to be able to fund you once you reach varsity. So they are preparing something for the future, but they are paying fixed amounts at regular intervals of time. So we call that future value annuity. We are paying for something for future. For example, someone depositing money every month in order to buy a car, in order to buy a house in future. We call that annuity a future value annuity. You understand? So yeah, we're just gonna start with future value annuity, and this is the formula. F is equals to x into 1 plus I exponent n minus 1 over I, right? So this formula was derived from geometric series, and that's how they got it. So capital is accumulated by means of regular equal payments into a savings account, payments, um, in a savings account or in an investment fund, right? So company interest is paid on the money deposited in the fund. So you'll find that once you're paying those regular fixed payments, you are getting some compound interest on your amount, right? So payments are made at the end of the month in the nominal formula. Very important, right? Payments are made at the end of the month. So with future value annuity, the normal way to do so is that you have to start paying at the end of the month. That's the normal procedure for future value annuities. You have to start paying at the end of the month. We'll talk about it when a person starts paying at the beginning of the month, what happens. But the normal thing is that you have to pay at the end of the month. Okay, let us look at this example quickly and see what's happening. So they said you want to save money to buy a house in 8 years time. The person wants to save money to buy a house in 8 years time, right? So the person decide to save 800 at the end of each month. So they're saving 800 at the end of each month in a savings account. The interest on the savings account is 7.8% compounded monthly. Very important. How much money will you have saved by the end of 8 years? What do they need? They need the future value. Why are we saying so? Equal payments are made. Equal payments of how much? 800 are made at the end of every month in order to save for something for the future. So we call this future value annuity because the person wants to buy a house. So we're just going to use a formula. It says future value is equals to what? X into 1 plus I exponent n minus 1 over, sorry about this, minus 1 over I, right? So what is your X? Now your X is those regular fixed payments that you are making. How much is it? It's 800. So just gonna substitute 800 there. Then let's see how it goes. 1 plus, what is your interest? Is 7.8%. So when you put your interest, you put it in decimals, right? You don't want to make a mistake there. The interest must be in decimals. So it's 0.078 divided by, remember it's compounded monthly. Then our interest must be divided by what? By 12, right? By 12. So what is N? So most of the learners make a mistake. They think N is the number of years. No. With annuity, N is the number of payments. Let me write it. Number of payments. Number of payments that you'll be making. Number of payments. How many payments have you made? Not number of years. Right? Remember, the person is paying 800 at the end of each month for 8 years. So in 8 years, how many months do we have? So it's just gonna be 8 times 12, right? So that's it, minus 1 all divided by interest, which is 0.078. Don't forget it's compounded monthly. We have to divide it by 12, right? So we're just gonna use the formula quickly and we get the answer. Simple as that. Simple as that. 1 plus 0.078 over 12 exponent 8 times 12 minus 1 into 0.078 divided by 12. So it's giving me 106167.85 rounded to 2 decimal place. So you can see that the person will make 106,167.85 cents. So that's the amount that the person will make. Okay, so let's look at a different problem now. If payment was made immediately. So you can see in this case, payment was made at the end of every month, right? The person didn't just open a savings account and start paying immediately. But let's take a look at a different example. Okay, here's it. Future value annuity when payment is made immediately. Okay, so what happens when payment is made immediately, right? Payment is made immediately. So most of the learners have just been told to memorize that on N you add 1, right? On your number of payments you add 1. But you have to understand, why do we add 1? Okay, we said the normal state for future value annuity is that payment must be made at the end of every month, right? So let me make a timeline. Maybe a person is supposed to pay for 1 year. Let me make a timeline for 1 year. And this is T0, T1, first month. Okay, let me make month 0, month 1, month 2, month 3, month 4, month 5. Let me just make it, maybe a person has to pay for 6 months, month 6. So it's 1, 2, 3, 4, 5, 6 months, right? Person has to pay for 6 months. But they made their payment immediately, right? It means here there was a payment, here there was a payment, end of every month, and they tell you payment was made immediately and also was made at the end of every month thereafter. So end of every month, end of month, end of month, end of month plus x plus x. X, remember, is the fixed payments. Take a look at how many number of payments are there. 1, 2, 3, 4, 5, 6, 7, right? So because it was 6 months, most people were going to say, okay, there are 6 payments made, right? But now it's different when the payment was made immediately. Take a look at this one. There's that other payment. So we say 6 payments plus 1 payment, making it how many payments? 7 payments. 7 payments. So this will be your N. Number of payment is 7 payment when you make payment immediately. So that's how it is, right? So let's actually take a look at this problem and just try to solve it and see where this leads us to. Okay, so they're saying, suppose at the beginning of the month 2000 is deposited into a bank. Very important, beginning of the month. So now it's a different future value problem. Why? It's because in the normal state, payments must be made at the end of the month, right? But now they're saying at the beginning of the month, 2000 has been deposited. It means we have an extra 1 payment, right? Because the normal state, you must pay at the end of the month. Okay, they said at the end of the month, a further 2000 is deposited and a further 2000 at the end of the next month. You understand? So he made a payment immediately at the beginning, and at the end he made 2000 end of another month they'll be making 2,000 like that. If the interest rate is 6% per annum compounded monthly, how much will have been saved after 5 years? So because here payments are made at a regular and they are fixed, they are made at regular intervals of time, we call this an annuity, right? So now it's a future value annuity because the person wants to just invest or save. So we're going to use future value formula. F future value equals to x into 1 plus I exponent n minus 1 over I, right? What is your x? Your x is the fixed payments that are made. So it's how much is 2,000. 1 plus what is your interest? 6%. So it's 0.06. Because it's compounded monthly, you divide by 12. N is the number of payment. Very important. That's where I want us to focus on, because most students make a mistake with N, right? Now look, how much is the person paying for? 5 years, right? So because it's compounded monthly, it's gonna be 5 times 12, which is gonna give you what? 60 payments, right? Because in 5 years we have 60 months. So it's gonna be 60 payments, right? But then very important, the person, there is another extra payment that was made at the beginning of the month. There's another 2,000. It means we're gonna add that one payment to give you 61 payment. Very important. So when you do future value annuity, be careful with your N, because that's where most students make mistake. So there's that extra payment at the beginning of the month. We know with future value annuities, the normal state is that you have to pay at the end of the month. So if you pay immediately, that is, if you pay at the beginning of the month, there is that extra payment, you have to include it. Then your number of payments will be 61. So that's it. It's 61. Where there is N, just gonna put 61 minus 1 divide by interest 0.06 divide by 12. Don't forget. So just gonna calculate using our calculator and see what's the correct answer. So the correct answer will be 142,237.76. So that's the final answer. 142,237.76 will be the money that will be saved. Okay. Let us now focus on present value annuity. Present value annuity. Remember, we said an annuity is what? An annuity is when a number of equal or fixed payments are made at a regular interval of time. It's like every time you're making certain payment in order to pay for something. Someone can be paying in order to build a house in future, in order for education of their learners, in order to buy a car, something like that. We call that future value annuity. But then with present value annuity, a fixed amount is paid each month to pay off a loan. To pay off a loan. You have heard of people borrowing and they were told make these regular payments. Maybe at the bank they said they will take this fixed payment at the end of every month. So in order to repay a loan, we call that present value annuity. So this is the present value formula. Here you can see it's very different from the future value formula. This is x into 1 minus 1 plus I into exponent minus n. Very important, minus n divided by I. So we know that px is the present value of the annuity or the loan amount. The loan amount. So we call it loan amount. So it's the money that you borrowed. X is the fixed, the regular payments or installments. I is the interest, and N is the number of payments, not number of years, number of payments or installments. Very important. Payments are at the end of the month and the loan is received at the beginning of the month. Very important, right? Very important. If the loan is received at the beginning of the month, it means you must start paying at the end of the month. Very important. Because it wouldn't make sense if you borrow money today, let's say it's the beginning of the month, and you have to pay it, start paying it same day. Doesn't make sense, right? So the normal condition with present value annuity is that payments must be made at the end of the month, right? If it was received at the beginning of the month, you have to start paying at the end of the month. After 1 month, you start paying. End of the month, you start paying. So very important. Let's take note. In general, loan repayments start 1 month after the loan was drawn, unless otherwise clearly stated. That's what we said. Hence, the loan repayments start at T1. You see, that's where your X start at T1. That's where your money starts. Just like in future value annuity, you start paying at the end of the month. Also with present value, that's some of the similarity. You start paying at the end of the month, right? At T1, that's where the first payment start. So which is the end of the first month. But you know that with future value you can start at the beginning, right? That's when your end changes to say there's that extra payment, you say +1 where there is end. But then it's different here. We'll see which is the end of the first month. It does not make any sense to take out a loan and immediately make a repayment, just as we have said. So in some situations such as home loans, it can be arranged that repayments only start 3 months after the loan is drawn. Let me talk about this because it's very important that you know how to deal with such problems, right? So I didn't cover it in this example, but let me just explain it in this page. So they said uh, it can be arranged that payments can start 3 months after the loan is drawn, right? What happens if they tell you the person start paying after 3 months? They delayed. We call it delayed payments, right? Delayed loan repayments. So if the person was expected to pay monthly, if the interest was monthly, the payment was supposed to be made monthly, and you go and start after 3 months, what happens? Your loan, which is your present value, your loan is going to increase by how many months? 2 months. Very important. So if the person was expected to pay monthly and the person start paying after 3 months, your loan is going to increase by 2 months. Why not 3 months? Because the person delayed with 3 months. No, the normal condition is that you have to start paying after 1 month. So they allow that 1 month is allowed, right? Then after that, the rest of the thing, your loan will be increasing because we said 3 months is T1, T2, T3. Look, they can allow you the first month. The normal condition is that the first month is fine. You can skip and start paying at the end of the month. You pay, right? But then look how many interval it will grow, how many time interval it will grow. If it was 3 months, this one is for 3 months, then you will see your loan will grow with two time intervals, not 3. You understand? So if you start paying after 3 months and you were expected to pay monthly, your loan will just grow with 2 months because the first month you're fine. They allow you because you can't just start repaying immediately. But then the other 2 months it will grow. Your loan will grow. Okay, what about N now? N remains the same. It is unchanged. The number of payments that you have to make, you still need to make the same payments. Whether you start after 3 months or what, you still have to make the same number of payments that you are expected to make. So it's different. You see, present value is different because where there is N, you don't change anything. You still have to pay the same number of payments that you are expected to repay in order to pay your loan. So very important to take note of that. And however, interest is charged from the day the loan is received, like that. Similarly, in starting business, it may be several months before the business start producing income, and repayments on the loan can be deferred by negotiation with the bank or financial institutions. So that's just some of the important things to notice. Okay, Let's quickly go to an example and see how it goes. Okay, let us take a look at an example for our present value annuity. It's from question 4, Department of Basic Education examination past paper. And this is the question. It says Sipokazi bought a house, right? She paid a deposit of 102,000 rands, which is equivalent to 12% of the selling price of the house. So it's just 12% of the selling price of the house, that 102,000 rands. So she obtained a loan from the bank to pay the balance of the selling price, right? To pay the balance of the selling price. Remember, 102,000 rands, it's just the deposit, which is equivalent to 12% of the selling price of the house. So she obtained a loan to pay for the remaining balance, right? So the bank charges her interest of 9% per annum compounded monthly. Compounded monthly. 4.1, determine the selling price of the house. Determine the selling price of the house, right? What we have now is that 102,000 rands is equal to 12% of the selling price of the house. It's just only 12% of the selling price of the house, right? So it's just 12% of the selling price of the house. 12% of selling price. Selling price. So when they say 12% of selling price, you remember in grade 9, of means we are multiplying, right? So it's basically be 102,000 rands is equals to 12% of its times selling price of the house. So in order to get the selling price, very simple, just divide by 12%. Divide by 12% both sides. Then this cancel this. Say 102 divided by 12%. It's gonna give you 850,000 rands as the selling price of the house. Selling price of the house. So that's the answer. Very simple. Maybe you might find they gave it three marks or 2 marks. So they just say 102,000 forms part of the 12% of selling price of, means we're multiplying, then divide by 12 per side. You solve for the selling price of the house. It's 850,000 rands. Or someone can do it this way to say, okay, 102,000 rands is equals to 12%, right? So what is the 100% of the house? 100%. X. Let X be the selling price of the house. When X is equal to 100%, what is the 100%? Then it's just going to be cross multiply. This is 102,000 multiplied by 100% is equals to X multiplied by 12%. You know that 100% is 1, but we can simply divide by 12% both sides, divide by 12% both sides. When you solve your X, you get it as 850,000 rands. That's the selling price for the house. Okay. Okay, let's now look at 4.2. The period of the loan is 20 years, and she started repaying the loan 1 month after it was granted, right? She started repaying the loan 1 month after it was granted. So this is the normal conditions, the normal thing that must be done. Like with loans, you have to start paying after 1 month. So it's good. So calculate her monthly installment. Calculate her monthly installment, right? So before calculating a monthly installment, we have to determine the present value first, P of X, right? Present value. They are low. Remember, she paid 102,000 only. From how much of the selling price? From 850,000. So we're going to say 850,000. We subtract the 102,000 that she paid, right, as a deposit. Then we see there's the balance that is left is the one that she borrowed, because she only had 102,000 in her pocket. So the loan will be 748,000 rands. That's the loan, right? So good. So we need X, which is the monthly repayments. The monthly repayments. Is it the monthly repayments? Yeah, it's the monthly repayments. So we're gonna use the formula present value is equals to X into 1 plus I exponent. No. This one is a future value. So it's X into 1 minus 1 plus I exponent minus N all divide by I. All divide by I. So in order to solve X, you can see that we can just simply cross multiply and get your X. So X, when you cross multiply, it will be P of X multiplied by interest divided by into 1 minus 1 plus I exponent minus N, right? So we can basically go and substitute there. What is your present value? It was 748,000 rands multiplied by what is your interest? The person was just 0.09% compounded monthly. Don't forget to divide by 12, right? Okay, so then we substitute 1 minus into 1 plus your interest 0.09 divided by 12. What is your number of payments? The person was supposed to pay for 20 years. So in 20 years, how many months do we have? 20 times 12, right? It will be 240. So it's minus 240 because it's 20 times 12. So it's the normal thing. Then we're just gonna get the answer there. Let's see. We're saying 748,000. 748,000 multiplied by 0.09 over 12 and divide by 1 minus 1 plus 0.09 over 12 exponent minus 240. Then we can get the answer. So the person must be paying a lot of money. It's actually 6,729.95 every month. 6,729.95. Okay, let us now look at question 4.3. They said, how much interest will she pay over the period of 20 years? Round your answer to the correct to answer correct to the nearest rands, right? Now we want to determine how much interest will she have paid within 20 years if she's gonna be making this deposit of 6,729.95 cents. So in order to get the interest, we are going to say how much did she pay over 20 years. So we are saying amount paid, we subtract the loan amount, or we can say, yeah, the loan amount. That's how we're gonna get our interest. Just say amount paid, how much did she pay, then we subtract the loan amount. So amount paid, she was paying 6,729.95, but she made these payments for 20 years, right? And she was paying them monthly, and we determined that to be 20 times 12, which is 240 payments made. 240 payments made. So she made 6,729.95, 240 of them, right? Then that's the amount she paid. We subtract the loan amount. What was their loan present value? She borrowed 748,000 rands. That was the loan, right? So let's now determine the interest. 6,729.95 times 240 is gonna give me 1 million. Just imagine 1,615,000 188 rands. It's a lot. Minus 748,000. You see, so it's because of they charged her some interest because she borrowed that money. So the interest that she paid over 20 years will be 867,188. Banks are making money, huh? Just imagine 867,188. It's even more than the amount she borrowed. You see, loans are really not that good. So that's the interest. It's 867,188 that was charged as the interest. Okay, let's now look at question 4.4, one of the most important questions in present value. They say calculate the balance of her loan immediately after her 85 installment. So after making 85 installments, calculate how much loan she will have, right? So that's called balance outstanding, outstanding balance of the loan. So how do you do this? There are two formulas that you can use, right? So I'll explain both formulas so that you may understand. Understanding is key. Understanding is key, especially when you're dealing with a chapter like this, financial mathematics. You have to understand, right? So after making 85 payments, what is their loan, right? So there's this formula. It says balance outstanding of a loan is equals to present value increasing with interest for a certain time like that. 1 plus I, let me use K, into minus, we subtract the future value of the money that it has grown in such period. So that's the formula. All right, I will explain this formula so that you may understand. So in order to determine how much is her balance outstanding after making 85 payments, we are saying let's take the loan that she had and let us increase it to 85, those 85 installments, to say after making 85 installment, how much would a loan grow to? You understand? How much would their loan grow to? So we are saying for 85 installment, which is like 85 months, how much will be her loan, right? After 85 installments. So we're gonna calculate it. The present value was 748,000. We are saying 1 plus interest, it was 0.09, compounded monthly 1285. So we are saying we want to determine how much will be her loan after 85 installments, right? So that's the first part of the formula. Then the second part of the formula is that because the person was making 6,729.95, what is the future values that she would have paid within those 85 installments? How much would she have reduced from her loan that has grown within the 85 installment? What is the future value of that money that she was paying? Then we subtract it, then we'll be left, whatever is left is the balance outstanding, the remaining loan. So I hope you understood that. So we are going to subtract 6,729.95, but we are saying this, we want to determine its future value, to say those money that she was paying, how much have they grown to within those 85 installments, right? So 0.09 over 12. So then we will just basically use a calculator in order to get the answer there. Okay, so you can see that the balance outstanding will be 6,015 615,509.77 right? Let me just repeat this because this is the most important part of our present value annuity. They said calculate a balance of the loan immediately after 85 payments. I'm explaining the formula, so that's where your understanding will come from, right? From the formula, we're saying within 85 months, how much has their loan grown to, right? So that's the first part of the formula, right? So the second part is saying, okay, within that 85 months, how much has she paid? You understand? So because she was paying 6,729.95, we're going to get the future value of the money that she was paying over 85 months. To say the loan has grown to this much, the person has managed to pay this much, then we subtract it, we get the balance outstanding, right? Okay, so there's another method that you can use to say this one is just this formula, this other formula. Let me just use a different color to say balance outstanding is equals to this other formula, say x into 1 minus 1 plus I, 1 plus I into minus into n minus k over I. So there's this other formula, right? So with this formula, we are going to say, okay, to get the balance outstanding, we are saying because the person has made 85 installment, out of how many installment, right? So the difference is n, out of how many installment? 240 installment. So we are saying in order to get the balance outstanding, let's just go and use the present value annuity and see how much will be her loan if she had already made 85 installment. From the end number of payments, how many payments are left? So we just say 240 minus 85, it's going to give us 155 payments that need to be made. So where there is a number of payments, we are saying 155 payments are left. Let's now calculate the loan amount, right? So let's use that formula and see. X is the number of fixed repayments, 6,729.95 into 1 minus 1 plus 0.09 over 12, exponent minus into, we know our n was 240 minus 85 because the person has already made 85 installment, divided by I, 0.09 over 12, right? So we're just going to use a calculator in order to get the answer there. Okay, so you can see that the final answer is 615,000 rands, 509.74. So you can see like the difference with these two formulas is just the decimal. So they won't penalize you for that because it's just different formulas and all that. We just, from this one, we are saying how many payments are left to be made. It's like 255 payments are left. Then you just use the present value formula to say the person will be making this for 155 payments that are left. Then that's the loan that the person has. Or this one to say how much has the loan grown to and minus the future value of the money that has been paid so far within that interval of time. So you can use any of these two formulas. I think this one is simple, but this one is more simpler for just understanding to say, okay, how much has my loan grown to minus the future value of the money that I've been paying so far. Okay, let's now look at question 4.5. They said she experienced financial difficulties after the 85th installment and did not pay any installment for 4 months. That is months 86 to 89. Calculate how much Sipokazi owns on her bond at the end of the 89th month, right? So what happens is that after making 85 payments, she experienced financial difficulties for 4 months. She was not able to pay for the 4 months, right? So calculate how much Sibokazi owes on her bond at the end of the 89th month, right? So how do we approach this question? Okay, so in order to answer it, we can look at the balance outstanding at the end of the 85 month to say after making 85 payments, how much is your loan now, right? And we already calculated it in 4.4. We know that the balance outstanding is what? Is 615,509.77, or you can use 74, doesn't matter, 0.77. Then we are saying she experienced financial difficulty for 4 months. How much does Sibukaze owns on her bond at the end of the 89th month? So we are saying the balance outstanding after making 85 payments, but then because she was not able to pay thereafter, right? So it means that the balance outstanding has now gained some interest over 4 months, right? Because she didn't pay thereafter. So that will be how much Sipokazi owns after at the end of 89 months. So we're going to compound this for 4 months. 0.09 over 12 to be compounded for 4 months because she was not able to pay it for that month. So 715 509.977 into 1 plus 0.09 over 12 exponent 4. So it will give us the money that she owns will be grow to 634,183.84. So that's the amount she owns. Let me repeat this. After paying 85 payments, she experienced financial difficulty for 4 months. How much does she owe, right? So what did we do? We calculate balance outstanding to say how much was her loan after paying 85 payments. You see, her loan was this one. Because she experienced financial difficulty for 4 months, because she was not able to pay, her loan will now grow or will now be compounded and gain some interest for 4 months. So that will be the final answer for the amount she'll be owing on your bond for 4 months. Okay, let's now look at the last question, which is 4.6. They say she decides to increase her payments to 8,500 per month from the end of the 90th month, right? How many months will it take to repay a bond after the new payment of 8,500 per month? So now it's if you can check these questions, they're interconnected, right? So in 4.5, you were asked to determine how much will be her loan after she has missed 86 to 89 payments. Now they are saying if now on her 90th payment she made 8,500 as every month thereafter, how much will it take her to repay the loan, right? So we need to know what is the loan uh, uh, after the 90th payments, like after the 89th payment, right? So that because at the 90th payment, that's where she start to make those 8,500. So we know that the loan after the making 89 payments was how much? We calculated it in 4.5. It's 6,304. I mean 634. Sorry for that. 634 about 183.84, right? So that's the loan, right? So now X has been increased to how much? To 8,500. 8,500. So they need how many payments can she make? How many months will it take? So we can calculate number of payments, right? So just gonna use P of X is equals to X into 1 minus 1 plus I exponent minus n over I, right? So that's it. P of X is what? It's 6,000, I mean 634, 183.84, then into 8,500 into 1 minus 1 plus 0.09 over 12 minus n divided by 0.09 over 12. So from that, we're going to solve for n, right? We're going to solve for n. How do we solve for n? We're going to divide both sides by 8,500, then we multiply with the interest. Then we take that thing to the other side and all that. Then, yeah, let's just do it. Okay, take a look at this one. We divided the loan by 8,500, we multiply with the interest, then it's going to give me 0.56. Then I take 1 to the other side plus 1, then it will give us what? It will give us it's 0.56 plus 1 is gonna be 1.56 is equal to minus it's minus, so it must be minus 1. Sorry about this, because 1 is positive, right? When it goes that side, it must be minus 1. Sorry about that. then it will be 0.56 minus 1, it's minus 0.44. We divide both sides by negative because there's this negative, then it will be 0.44 is equal to 1 plus 0.09 over 12 exponent minus n. So n is at the exponent. In order to solve it, I'm just going to take this thing up here because of space. We don't have space here. I'm just going to take it up there and solve it. Then to take n down, we're going to use log rules, right? So we apply log both sides, log 0.44, then log also that side. When you apply log to the other side, your minus n will come down and you'll be left with log 1 plus 0.09 over 12. So in order to solve n, we're going to divide both sides by minus log 1 plus 0.09 over 12. So divide by minus log 1 plus 0.09 over 12. So we can get the answer there. Okay, when we solve n, our n will be 109.74. So we can answer the question, how many months will it take to repay a new payment, a repayment of the bond? It will take 109 months. We can assume probably it will be 110 month, right? 110 months. So if we round it off to the nearest month. Okay. All right, great stuff. Interesting part of our lesson now. Sinking funds. Sinking funds. What is a sinking fund? So very important. Financial mathematics understanding is key. Actually, in all topics, understanding is key. So what happens? Okay, when equipment is bought, right, provision has to be made to replace the equipment in the future, right? For example, companies like companies that are having photocopying machines, they know that in the future they'll need to replace those machines. They'll be old and maybe not functioning anymore. So they open this account where they will be saving money in order to prepare for repaying or replacing those photocopying machine maybe after a certain period of time, right? So we call that account a sinking fund, right? So you now know a sinking fund is an account that is opened where maybe mostly by companies in order to save money, in order to replace some of the items that won't be functioning in future. So in order to replace those equipment in future, so we call this a sinking fund. So this is done by means of a sinking fund where regular payments are made in order to save for the replacement of equipment. So that account is called the sinking fund. So to set up a sinking fund, the following has to be calculated. What the old equipment will be sold for in the future, right? For example, we know if I bought a photocopying machine and I'll need to replace it after 10 years, right? If I bought it today by maybe 850,000, after 10 years, your photocopying machine has depreciated, right? Has lost its value. So you need to calculate how much has uh, is its book value or it's the amount that you can sell with if you want to sell that old machine, because it has lost its value after 10 years. It won't even cost that 850,000 that you bought with. So this need to be calculated first. We use depreciation in order to calculate how much as the equipment reduced to, right? So what is the new equipment? What new equipment will cost in future? We also need to calculate this, what new equipment will cost in future. For example, the new machine that is inside the store, that was 850 when you buy it. After 10 years, you won't buy it with 850. It has gained some interest because that's an equipment, that's an asset, and the assets are always like gaining interest over time. So it has gained some interest over 10 years. So you'll need to calculate, you use inflation to say, okay, maybe that's telling you, okay, this item will gain like 7% every year. So you need to know how much is the new machine that I'm gonna buy there, right? So now the difference of these two values, that is the inflated value and the depreciated value, is the future value, is the total amount that you have to pay in order to buy that new machine. Because what you're gonna do, you're gonna sell your old machine with that value that it has reduced to, but then after selling it, that other new machine in the shop has grown up. I mean, the price has grown, right? So you use the money you have you made by selling the old machine towards paying for the new machine. So the difference there would be the future value, and that has to be saved in order to replace that equipment by that time, right? Okay, so we call this whole procedure, it's like for sinking funds. It's that saving account. Let me repeat, the saving accounts where equal payments are made in order to replace an item in the future. Okay, let's just take a look at an example, and we just take it from there. Okay, sinking funds example. Got this example from WTS tutoring document from Department of Basic Education Examination past papers. So it says, Kangelani's small business called WTS tutoring purchased a photocopying machine for 200,000 rands. The photocopy machine depreciates in value at 20% per annum on reducing balance, right? So they say Kangalan's business wants to buy a new machine in 5 years' time. So they'll need to replace that one. A new machine will cost much more in future, and its cost will escalate at 16% per annum effective, right? The old machine will be sold as scrap value after 5 years. It means like the book value of the old machine will be used towards paying for the new machine, right? So a sinking fund is set up immediately in order to save up for the new machine. The proceeds from the sale of the old machine will be used together in the sinking fund to buy the new machine, what I just said. So the small business will pay equal monthly amounts into a sinking fund, and interest earned is 18% per annum compounded monthly. So the first payment will be made immediately, and the last payment will be made at the end of the 5-year period. At the end of the 5-year period. So there's some sort of lots of restriction and all that, but it's a very simple question. Let's start with I. Find the scrap value of the old machine, right? The scrap value. So scrap value is like sometimes called the book value, right? The book value, that is the value that the machine has depreciated to. So we know that it has depreciated using reducing balance method. So our A is going to be P into 1 minus I exponent N, because because it's depreciating compound because it's a reducing balance method. So that's it. So we want to see how much was the 200,000 has been reduced to 1 minus depreciated by 20%, which is 0.2, after how many years? 5 years. So we want to calculate after 5 years how much will be our scrap value. Okay, so our scrap value will be 65,536. So it will be less after 5 years. The machine is old. You mean you won't sell it with the same price. It has reduced to that amount. Okay, let's now look at the second question. Find the cost of the new machine in 5 years' time, right? In 5 years' time, what is the cost of the new machine? Remember, the machine has been getting interest, right? So they told you a new machine will cost much more in future and it will escalate at 16% per annum effective, right? So the cost of the new machine is just going to gain interest 1 plus I within that period of time. So it was 200,000, but they say it will escalate by 16%, which is 0.16. We want to see how much will be the cost of the new machine after what? After 5 months. After 5 months, we need to determine the cost of the new machine. Okay, so when we use our calculator, it's gonna give us 420,068 rands 0.33. 420,068 rands 0.33. Okay, so that will be the cost of the new machine. It will have increased from 200,000 to 420,000 and 68.33. Okay, very interesting question. Roman figure 3. Find the equal monthly payments made into the sinking fund. Find the equal monthly payments made into the sinking fund, right? But you know that in a sinking fund, we need to get the future value, right? To say what is the future value that has to be paid towards saving for purchasing the new machine, right? So the future value now we are going to say, because they said the scrap value will be used towards paying for the new machine. After 5 years, the new machine is now this price, right? It's now 420,068 rands 0.33. But then we need to know how much should a person save for, right? In order to pay the new machine. But we know that they are going to sell their old machine with this price because that's the scrap value or the book value with 65,536. Then we can get the future value, right? Future value will be 420,068.33 minus 65,536, right? So the future value, the amount that they need to save now is 354,532.33. So this is the amount that this tutoring company has to start saving for in order to buy the new machine, right? But the question requires us to find the equal monthly payments that will be made into this sinking funds, that will be made into this sinking fund, right? Don't forget that the first payment was made immediately, and this is future value. What happens? There will be an extra payment. It will be +1. Then thereafter, they will be making payments at the end of every month, right? So just gonna use future value formula is equals to x into 1 plus I exponent n minus 1 over I, right? So our x, obviously it will be future value into 1 plus I exponent n minus 1 over I, right? So x, what is our future value? We need to save 354,532.33 divided by then this one plus your interest was how much? So in the sinking fund, the interest n was 0.1, I mean 18% per annum compounded monthly. So 0.18 over 12. Then for 5 years, in 5 years it will be 5 times 12, which is how much? 5 times 12, which is 60 payments. But because payment was made immediately, be very careful there is that one extra payment. So +1, then it will be 61 payments that will be made, right? So yeah, it will be 61 minus 1 over 0.18 over 12, right? 0.18 over 12. Then we can just simply get the answer for our x there using a calculator. Okay, so our monthly repayments, our monthly payments must be 3,593.55. 3,593.55. It means at the end of every month, this company needs to be paying in their sinking funds 3,593.55 in order to meet this future value so that they can be able to purchase the new machine after 5 months. All right. Okay, great stuff. Let's look at this last question. Interesting question. They say, suppose that the business decides to service the machine at the end of each year for the 5-year period. So 3,000 will be withdrawn from the sinking fund at the end of each year, starting 1 year after the original machine was bought. Right. So now the question is calculate. Let me write it. There's no question in this one. So it say calculate the monthly payments that should be made in order to cover for the service of the machine. So calculate the monthly repayment that should be made in order to cover up for the service of the machine. So 3,000 has to be withdrawn to in the sinking fund, right? In order to pay for what? For the service of the machine. So let's calculate how much monthly payments that the company should be making in order to also cover for the service of the machine, right? So now you can see that 3,000 is withdrawn at the end of each year, right? It's at the end of each year. So in order to calculate this one, we're just going to use future value formula to say monthly repayment is equals to future value over future value multiplied by interest over 1 plus I exponent n minus 1. So that's the formula for x. Now the future value, 3,000 is withdrawn at the end of every year. And they need to service the machine for 5 years, right? For 5 years, right? So the mistake that most students do, they just think the future value to be 3,000 multiplied by 5 because it's at the end of every year they need to be withdrawing this month. But no, so it's really not like this, because if you do this, you'll have to convert interest into from monthly to yearly, so that you may, because your future value is in yearly, so you need to convert, and it will be the whole lot of process, right? So what you do is that you can just consider it for that 1 year that 3,000 is withdrawn, right? In that 1 year, so future value will just be 3,000. So the interest is what? 0.18, because on the second fund is 0.18 per month, right? So that's the future value in 1 year. We have 12 months, so it will be 1 plus 0.18 over 12 exponent exponent what? Exponent 12, because we want to see, we're just using for 1 year to say 3,000 must be withdrawn for 1 year. In 1 year we have how many months? We have 12 months. We want to see the monthly repayments that need to be made in order to service for this thing. That's why on our number of payments is just 12 months, because in 1 year we have 12 months. So minus 1, like that. Then you can determine the final answer there. Okay, so the final answer will be 203 rands point 4 cents. 200, sorry about this. It's 203 rands 0.4 cent. So that's what need to be saved every month in order to be able to withdraw 3,000 every year in order to pay for to service the machine. All right. Okay, great stuff. This marks the end of our lesson. Thank you very much for watching. Thank you very much for joining me today. Thank you for your time. I hope you learned something, and good luck with your final examination. All the best. That's all from me, Ndondibuo. Thank you.